An indicator is a substance that is used to help determine the pH in a solution. So basically what an indicator is that it's a substance that you put into a solution of either ammonia, anything, and it will help determine the pH. The way this happens is through the dissociation of the ions in the molecule, and you'll get hydrogen ions and hydroxide ions that both have different colors, and they will reflect in the solution.
The color change of an indicator is related to the pH because each indicator at a certain pH will give an acid or a base a certain color. For example, if thymo blue is at a pH range of 1.2 to 2.8, it'll give the acids a reddish color and the bases a yellowish color. As you can see, in this example, we put 1 drop of thymo blue into 10 drops of ammonia. And when we did that, it gave ammonia a yellowish color. Therefore, it's a base. When we put the thymo blue into lemon juice, it gave us a reddish color, so we determined it was an acid. Although the color isn't very red, it is closer to red than yellow. Therefore, it's an acid. Now, you see us putting thymo blue into soap. Soap is a base, and it gave it a color of yellow, proving it is a base. When we put it into the vinegar, it was more orange-red on the red side, so it's an acid. When we put it into the bleach, it was very, very light yellow, so it's a base. And when we put it into the soda, it was more on the yellow side than red, so it's a base. Next, we added bromophenol blue to all the common household items. Bromophenol blue turns acids yellow and bases blue-violet. Ammonia turned blue-violet, so it is a base. Next, we have lemon juice, which turned yellow, therefore it's an acid. Now we have vinegar. It is also yellow, so it's an acid. When we put bromophenol blue into bleach, it turned blue indigo right away, and then quickly after it turned clear. Therefore it is a base because it turned indigo blue at first. It turned soap blue as well, therefore it is a base. For soda, we got more of a yellowish color than blue, so it's an acid. Bromocresol green at a pH of 4.0 through 5.6 makes acids yellow and bases blue. It turns ammonia blue, so it is a base. It turns lemon juice yellowish, so it is an acid. It turns vinegar orangish, which is on the yellow side, so it's an acid. It turns bleach yellowish, so it's an acid. It's very light yellow, but it's yellow. Next, we have soap. It turns soap very dark blue, so it's a base. Soda almost looks brown, but in fact it is very dark yellow, so it's an acid. Methyl orange at a pH of 3.1 to 4.4 makes acids red and bases orange. Ammonia was turned orange, so it is a base. Lemon juice was turned red, so it is an acid. Vinegar was also turned red, so it is also an acid. Bleach, it looks clear in the picture, but right when we put it in, it was red, so it is an acid. Soap is a base, it turned orange. Soda was red, so it is an acid.
When we put the litmus paper into the ammonia, there was no change in the color, meaning that it was a base. When we put the litmus paper into the lemon juice, it turned pink, showing that it was an acid. When we put the litmus paper into the soap, it turned blue, showing that it was a base. When we put the litmus paper into the vinegar, it was red, and there was no change, showing that it was an acid. When we put the litmus paper into the bleach, it turned white, meaning that it was an acid. And when we put the litmus paper into the soda, it stayed red, meaning that it was also an acid. When we put the 1 drop of universal indicator into the ammonia, it turned light teal, showing that it was a base. When we put the 1 drop of universal indicator into the lemon juice, it turned light red, showing that it was an acid. When we put the 1 drop of universal indicator into the soap, it turned orange, and it showed us that it was an acid as well. When we put the universal indicator into the vinegar, it turned into a pinkish reddish type of color, showing that it was also an acid. When we put the universal indicator into the bleach, it turned like a kind of light green, showing that it was a base. And when we put the universal indicator into the soda, it turned red, showing that it was also an acid. When we put the pH paper into the ammonia, pH paper turned light green, showing that it was a base. When we put the pH paper into lemon juice, pH paper turned dark red, showing that it was an acid. When we put the pH paper into soap, pH paper turned yellow, showing that it was an acid. When we put the pH paper into vinegar, pH paper turned orange with no change, showing it was an acid. When we put the pH paper into bleach, pH paper turned light green, showing that it was a base. And finally, when we put the pH paper into the soda, no change, and it turned into an acid. When we put phenolphthalein into ammonia, it turned pink, showing that it was an acid. When we put phenolphthalein into lemon juice, it stayed clear, showing that it was also an acid. When we put phenolphthalein into soap, it had no change, showing that it was an acid. When we put phenolphthalein into vinegar, it stayed clear, showing that it was an acid. When we put phenolphthalein into bleach, it also stayed clear, showing that it was also an acid. And finally, when we put phenolphthalein into soda, it too stayed clear, showing that it was also an acid. When we put methyl red into ammonia, it turned light orange, showing that it was an acid. When we put methyl red into lemon juice, it turned pink, showing that it was an acid. When we put methyl red into soap, it turned red, showing that it was also an acid. When we put methyl red into vinegar, it turned dark pink, showing that it was an acid. When we put methyl red into bleach, it stayed clear, showing that it was an acid. And finally, when we put methyl red into soda, it turned dark pink, showing that it too was an acid.